explain working of optical current transformer with figure. So here you can visualize the constructional diagram or the figure of the optical current transformer. Already we have seen the constructional details or the features or the type of construction for the optical current transformer. It is mainly a combination of three different subsystems together forming the optical current transformer. The process begins in the electronics unit where a light source, typically a laser or superluminescent diode, generates a steady beam of light. The light travels away from the source and moves through an optical fiber cable towards the high voltage conductor. You can visualize this. The high voltage conductor is here in this. Before reaching the sensing area, here you can see this about this. Here in the enclosure, the optical fiber is here through which the light is traveled from source to this place. Now before reaching the sensing area, the light passes through a polarizer which filters the wave so that only vibrate in one direction the wave can be, and creating linearly polarized light. The polarized light then enters to the sensing elements, which is usually a coil of optical fiber wrapped around the conductor carrying the electrical current. Here it is, the secondary. This. Understood? Now, as the electrical current flows through the high voltage conductor, it creates a magnetic field that surrounds the wire and permeates the fiber coil. Permeates. So, permeability means the magnetization is linked with it, or the medium's magnetic strength is improved. When the light travels through this magnetic field, a phenomenon called the Faraday effect occurs. The Faraday effect causes the polarization angle of the light wave to rotate continuously, means linear form to the rotary form. The extent of this rotation is directly proportional to the strength of the magnetic field, which itself is determined by the amount of current flowing through the conductor from the primary winding of the primary conductor. Now consequently, a higher current results in a larger rotation of the light's polarization angle, while a lower current results in the smaller rotation, because the higher current have the highest magnetic field strength, whereas the lower has the lower one. So by this we can easily compare the rotation. The light now carrying this rotation information exits the sensing coil and travels back down to a return optical fiber to the ground level electronic circuits. Upon returning, the light enters an optical analyzer or splitter, which detects the change in the polarization angle. This optical component converts the angle rotation into a measurable change in the light intensity. Photodetectors then receive this light and convert the varying light intensity into the analog electrical signal. A digital signal processor finally analyzes this electrical signal to calculate the precise current value flowing in the high voltage line. So this is how the optical current transformer works.